You're about to discover why Formula One cars from the 1980 seconds were absolutely insane machines that would make today's drivers question their life choices. We're talking about cars with no speed limits, engines that literally exploded for more power, and safety features that basically didn't exist. By the end of this video, you'll understand why the 80s were both the most thrilling and terrifying decade in Formula One history. The 1980 seconds marked a revolutionary period in Formula One that transformed racing forever. While today's F1 cars are marvels of engineering precision and safety, the machines from 4 decades ago were raw, untamed beasts that pushed the boundaries of physics and human endurance in ways that seem almost reckless by modern standards. Let's start with something that will blow your mind. The turbo engines of the 1980 seconds were so powerful that teams would literally blow them up on purpose during qualifying. These weren't accidental explosions we're talking about here. Teams would tune their engines to produce maximum power for just one flying lap, knowing full well that the engine would self-destruct immediately afterward. The BMW turbo engine, for example, could produce over 1,400 horsepower in qualifying trim. To put that in perspective, that's more power than some of today's Indy cars, crammed into a chassis that weighed about the same as a modern compact car. The qualifying sessions were pure madness. Drivers would go out for 1 or 2 laps maximum, push the car to its absolute limit, and then watch smoke pour out the back as the engine grenaded itself. Teams would go through multiple engines per weekend just for qualifying attempts. The sound alone was otherworldly. Imagine the most aggressive turbo whistle you've ever heard, multiplied by 10, accompanied by the violent crackling of an engine operating at the very edge of mechanical possibility. But here's where it gets really wild. These engines weren't just powerful, they were completely unpredictably. The turbo lag was so severe that drivers would have almost no power coming out of slow corners, then suddenly get hit with a massive surge of boost that could send them spinning into the barriers without warning. Nelson Piquet once described driving a turbo F1 car as like trying to control a wild animal that could turn on you at any moment. The fuel consumption was equally ridiculous. These cars were so thirsty that teams had to develop incredibly sophisticated fuel management strategies just to finish races. Drivers would spend entire race weekends learning how to short shift, lift and coast, and manage their throttle inputs to make it to the checkered flag. Some drivers became so skilled at fuel saving that they could extend their stint by managing consumption down to the milliliter. Speaking of fuel, let's talk about the exotic brews these engines consumed. Teams weren't just using regular racing gasoline. They were concocting custom fuel blends that were more like rocket fuel than anything you'd put in a streetcar. These special fuels could increase power output by significant margins, but they were also incredibly volatile and expensive. Some fuel mixtures cost more per liter than vintage champagne. The aerodynamics of 80s F1 cars were in a completely different universe compared to today's machines. Ground effect was the name of the game, and teams were creating cars that generated massive amounts of downforce through Venturi tunnels built into the floor of the chassis. These cars could theoretically drive upside down at high speeds because they were generating more downforce than they weighed. The problem was that if airflow was disrupted even slightly, the car would instantly lose all its grip and become completely uncontrollable. This led to some of the most spectacular crashes in F1 history. When ground effect cars lost their aerodynamic grip, they didn't just slide off the track gracefully. They would launch into the air, barrel, roll multiple times, and disintegrate in ways that defied physics. The fact that drivers regularly walked away from these incidents was nothing short of miraculous. The suspension technology was primitive by today's standards, but teams were incredibly creative in working around the limitations. Some cars used suspension systems that were manually adjustable from the cockpit, allowing drivers to change the car's handling characteristics on the fly. Other teams developed active suspension systems that could automatically adjust to track conditions, though these early systems were notoriously unreliable and could malfunction at the worst possible moments. Let's dive into the bizarre world of 80s F1 tires. The tire war between Michelin, Goodyear, and other manufacturers was intense, and teams would sometimes show up to races with completely experimental tire compounds that had never been tested under race conditions. Qualifying tires were so soft and grippy that they would literally fall apart after a few laps, leaving chunks of rubber scattered around the track. Some drivers reported that they could feel the tires degrading in real time during their qualifying runs. The wet weather tires were equally extreme. Teams would show up to rainy race weekends with tires that had tread patterns so aggressive they looked more like tractor tires than racing slicks. These tires could clear enormous amounts of water, but they were so specialized that if the track started to dry even slightly, drivers would be sliding all over the place. Now let's talk about something that will make your jaw drop. The safety standards in 80s Formula One were practically non-existent by today's measures. Drivers wore helmets that would be considered inadequate for go-kart racing today. The fire suppression systems were basic at best, and many cars didn't even have proper roll cages. Drivers would climb into these missiles on wheels, wearing equipment that offered minimal protection, knowing that a high-speed crash could easily be fatal. The medical facilities at many circuits were woefully inadequate. Some tracks had medical centers that were little more than first aid stations, and helicopter evacuation wasn't always available. Drivers were essentially risking their lives every time they took to the track, and everyone involved knew it. The fact that there weren't more fatalities during this era is remarkable. But perhaps the most shocking aspect of 80s F1 safety was the attitude toward it. Many drivers and team personnel viewed safety equipment as unnecessary weight that would slow the car down. Some drivers would actually remove safety equipment between practice sessions to save weight, then put it back on just before qualifying or the race. The mentality was completely focused on performance at any cost. The technical regulations were much looser than today, which led to some absolutely wild innovations. Teams were constantly pushing the boundaries of what was legal, and the rulebook was rewritten constantly to keep up with creative interpretations. Some teams developed cars with movable aerodynamic devices that could be adjusted during the race. Others created suspension systems that technically complied with the rules but functioned in ways the rule makers never anticipated. One of the most fascinating aspects of 80s F1 was the rapid evolution of technology throughout the decade. A car that was competitive at the beginning of the decade would be laughably obsolete by the end. Teams that couldn't keep up with the technological arms race would find themselves backmarkers almost overnight. The rate of development was so intense that some teams would introduce major upgrades to their cars every single race weekend. The political battles behind the scenes were equally dramatic. The governing body was constantly trying to rein in costs and technical complexity, while teams were doing everything possible to gain competitive advantages. Some technical innovations were banned almost as quickly as they were introduced, leading to heated disputes and legal challenges that sometimes lasted years. The drivers of the 80s were a special breed. They had to be incredibly physically fit to handle cars that had no power steering, primitive ergonomics, and generated enormous G-forces. Many drivers would lose several pounds during a single race from the physical demands and extreme heat inside the cockpit. The mental toughness required was equally impressive, as drivers had to maintain focus while managing incredibly complex and unpredictable machines at speeds that would terrify most people. The preparation required to drive these cars was intense. Drivers would spend hours studying telemetry data, working with engineers to understand the car's behavior under different conditions, and practicing techniques for managing the various systems. The learning curve was steep, and rookie drivers often struggled for entire seasons just to understand how to extract performance from these complex machines. The pit stop strategies of the 80s were completely different from today's rapid-fire tire changes. Pit stops were primarily for fuel, and they could take anywhere from 15 to 30 seconds. Teams had to carefully calculate fuel loads at the start of races, balancing performance against the need to make it to the finish. Some teams would gamble on fuel strategy, starting races with minimal fuel loads and hoping that weather conditions or safety car periods would work in their favor. The communication between drivers and teams was primitive compared to today's standards. Radio systems were unreliable and often failed completely during races. Drivers had to rely on hand signals from crew members during pit stops and pit board messages for race information. This meant that drivers were often racing blind, making split-second decisions without full information about their competitors or race. Strategy. The financial aspects of 80s Formula One were wild in completely different ways than today. While the total budgets were smaller in absolute terms, teams were spending money on incredibly exotic and experimental technologies that often had no practical application beyond Formula One. Some teams invested massive amounts in wind tunnel research, while others focused on metallurgy and exotic materials that were pushing the boundaries of what was possible. The reliability challenges were constant and dramatic. Cars would regularly fail due to the extreme stresses placed on every component. Engine failures weren't just common, they were expected. Teams would often prepare multiple spare cars for each driver because the likelihood of mechanical failure was so high. Drivers who finished races in these cars had accomplished something genuinely impressive, regardless of their final position. As we wrap up this journey through the insane world of 80s Formula One, it's clear that this decade represented a unique moment in motorsport history. These cars were technological marvels that pushed every boundary imaginable, operated by drivers who possessed courage that borders on the supernatural, supported by teams that were willing to risk everything for competitive advantage. The legacy of 80s F1 continues to influence racing today, though in ways that are often invisible to casual observers. Many of the fundamental technologies that make modern F1 cars possible were first developed and tested during this wild decade. The lessons learned about aerodynamics, engine management, and materials science during the 80s provided the foundation for everything that came afterward. If you enjoyed learning about these incredible machines, make sure to subscribe for more deep dives into Formula One history. Drop a comment about which 80s F1 car you think was the most insane, and hit that notification bell so you don't miss our upcoming videos about the legendary drivers who tamed these mechanical beasts. Hold up, did you know that Formula One cars in the 1,990 seconds were literally trying to kill their drivers? I'm not being dramatic here. These machines were so ridiculously overpowered and underregulated that they were basically four-wheeled death traps wrapped in carbon fiber. And somehow, that made for the most incredible racing we've ever seen. Picture this. You're strapped into a cockpit so tight you can barely move, with over 700 horsepower screaming behind your head. No power steering, no traction control for most of the decade, and aerodynamics so primitive that the car could randomly decide to take flight at 180 miles per hour. Welcome to 90s Formula One, where physics was more of a suggestion than a law. But here's the thing that'll blow your mind. These cars weren't just dangerous. They were absolutely bizarre, in ways that would make today's engineers have nightmares. We're talking about vehicles that needed custom-built ovens just to heat up their tires, engines that literally exploded if you looked at them wrong, and safety features that were about as sophisticated as a cardboard box. Today, I'm going to take you inside the wild world of 1,990 seconds Formula One cars, and trust me, by the end of this video, you'll understand why this decade was simultaneously the most terrifying and most spectacular era in motorsport history. We're diving deep into the insane engineering, the deadly physics, and the absolutely bonkers innovations that made these cars legendary. Let's start with something that sounds innocent but was actually terrifying: the tires. Now, you might think tires are just rubber circles, right? Wrong. In the 90s, Formula One tires were like temperamental divas who demanded perfect conditions or they'd throw a lethal tantrum. These tires had to be heated to exactly the right temperature before they could even grip the track properly. We're talking about tire warmers that looked like giant sleeping bags, wrapping around each wheel and pumping heat into the rubber. But here's the crazy part. The temperature window for optimal grip was so narrow that being off by just 10 degrees could mean the difference between setting a lap record and sliding straight into a concrete barrier at 150 miles per hour. And speaking of temperature, the tire pressures were so critical that teams had engineers whose entire job was just to monitor tire pressure. These guys would be running around with digital gauges that cost more than most people's cars, checking pressures every few minutes because even a tiny change could catastrophically alter the car's handling. But wait, it gets weirder. The tires themselves were basically made of a special compound that was harder than normal road tires when cold, but turned into this incredibly sticky substance when heated up. Think of it like chewing gum that's been sitting in your freezer versus chewing gum that's been in your mouth for 5 minutes. The difference in grip was so dramatic that drivers literally couldn't drive the car properly until the tires reached operating temperature. Now, let's talk about the engines, because this is where things get absolutely insane. The most iconic engines of the decade were the V10S and V12S, and these things were mechanical masterpieces that also happened to be ticking time bombs. Take the Ferrari V12 engines that powered cars like the 412-ton series. These engines were producing over 700 horsepower from a 3.5-liter displacement, which means they were generating more power per liter than most modern supercars. But here's the kicker. They had to be completely rebuilt after every single race weekend. Not repaired, not tuned up, completely torn apart and rebuilt from scratch. The tolerances in these engines were so tight that the pistons had maybe 0.5 millimeter of clearance from the cylinder walls. When the engine heated up during a race, everything would expand, and if the tolerances weren't perfect, the engine would seize up completely.
And when I say seize up, I mean it would literally weld itself together and potentially catch fire. But the really wild part was the rev limits.
These engines were spinning at over 15,000 revolutions per minute, which is so fast that the pistons were experiencing gravitational forces that would make an astronaut sick. The connecting rods had to be made from exotic materials that cost thousands of dollars each just to prevent them from snapping under the incredible stress. And here's something that'll make you appreciate modern technology. These engines had no electronic engine management systems for most of the decade. Everything was mechanical. The fuel injection, the ignition timing, even the rev limiters were all controlled by mechanical systems that had to be adjusted by hand with tiny screwdrivers and specialized tools. Speaking of fuel, let's talk about the gas these cars were drinking. It wasn't regular pump gas, obviously, but it also wasn't the highly regulated fuel that Formula One uses today. Teams could basically brew their own custom fuel blends, and some of the concoctions they came up with were absolutely wild. Some teams were using fuel additives that were technically legal, but completely insane. There were rumors of teams adding everything from aviation fuel components to exotic octane boosters that cost more per gallon than vintage champagne. The fuel was so volatile that it had to be stored in special containers and handled with extreme care because it could ignite at much lower temperatures than normal gasoline. But the fuel system itself was equally crazy. The fuel pumps had to maintain incredibly high pressure to keep up with the engine's demands, and if the pressure dropped even slightly, the engine would lean out and potentially melt pistons in seconds. Teams had backup fuel pumps, backup fuel lines, and backup systems for the backup systems. Now, let's get into the aerodynamics, because this is where 90s Formula One cars really showed their wild side. The aerodynamic packages on these cars were developed through a combination of limited wind tunnel testing and basically educated guessing. Teams didn't have the sophisticated computer simulations that exist today, so a lot of aerodynamic development was trial and error. This led to some absolutely bizarre-looking cars. Take the Tyrrell 025 from 1997, which had this strange stepped nose that looked like someone had taken a bite out of the front of the car. Or consider the McLaren MP4-11 from 1996, which had side pods that were so aggressively sculpted they looked like they belonged on a spaceship rather than a race car. But here's the really scary part. The aerodynamic balance of these cars was so sensitive that hitting a small piece of debris could completely change the car's handling characteristics. A small piece of rubber from another car's tire could stick to the front wing and suddenly make the car undrivable. Drivers would have to pit just to have mechanics remove debris that weighed maybe a few ounces. The ground effects were equally wild. These cars generated so much downforce that at high speeds, they could theoretically drive upside down on the ceiling of a tunnel. But the downforce was so dependent on the car's ride height that hitting a bump or a curb could suddenly reduce the downforce by hundreds of pounds, causing the car to lose grip instantly and unpredictably. Let's talk about the transmissions, because these were mechanical marvels that also happened to be incredibly temperamental. Most cars in the early 90s still used manual transmissions with a clutch pedal, but by the mid-90s, teams were experimenting with semi-automatic gearboxes that were the predecessors to today's paddle shift systems. These early semi-automatic systems were incredibly crude compared to modern standards. The gear changes took several hundred milliseconds, which sounds fast until you realize that modern Formula One cars can change gears in less than 50 milliseconds. And if the system failed, which happened regularly, drivers would be stuck in whatever gear they were in when it broke. But manual transmissions had their own challenges. The gear ratios were fixed for each track, so teams had to predict exactly what ratios would work best for each circuit. Get it wrong, and you'd either be hitting the rev limiter on the straights or lugging the engine through slow corners. There was no adjustability once you were on track. The clutches were equally demanding. They were designed to be as light as possible, which meant they had very little thermal mass. During a standing start, drivers had to manage the clutch so precisely that too much wheel spin would overheat the clutch and cause it to fail, while too little would bog down the engine and cost crucial positions. Now, here's something that might surprise you. The steering systems in these cars were completely different from modern Formula One cars. There was no power steering assistance whatsoever. Drivers had to muscle these cars around the track using pure arm strength, and at high speeds, the steering forces were so high that drivers needed serious upper body strength just to turn the wheel. This created some interesting dynamics. Drivers had to develop incredible forearm and shoulder strength, and races became as much about physical endurance as driving skill. By the end of a 2-hour race, drivers' arms would be burning from the constant effort of fighting the steering wheel. But the lack of power steering also meant that drivers got much better feedback from the front wheels. They could feel exactly what the tires were doing, whether they were losing grip, hitting bumps, or running over debris. Modern drivers often say they miss this direct connection between the car and their hands. The suspension systems were equally primitive by today's standards, but incredibly sophisticated for their time. Teams were using exotic materials like titanium and carbon fiber for suspension components, not for weight savings, but for strength. The forces going through the suspension during high-speed cornering were so extreme that regular steel components would simply break. But here's the crazy part. Teams were also experimenting with active suspension systems that used computer-controlled hydraulics to constantly adjust the car's ride height and handling characteristics. The Williams cars with active suspension were so dominant that they essentially broke the sport, leading to the technology being banned. These active suspension systems were like having a computer driving the car's suspension in real time. The system would analyze hundreds of inputs per second and make tiny adjustments to optimize the car's aerodynamics and mechanical grip. When it worked, it was like magic. When it failed, which happened regularly, it was catastrophic. Let's dive into the safety equipment, because this is where you really understand how different the 90s were from today. The helmets look similar to modern ones, but they were significantly heavier and provided much less protection. The safety standards were evolving rapidly during the decade, driven by several tragic accidents that highlighted the inadequacies of existing safety measures. The racing suits were made from materials that provided basic fire protection, but they were nowhere near as sophisticated as modern suits. Drivers regularly suffered burns from fuel fires or hot exhaust components, injuries that would be almost impossible with today's safety equipment. But the most shocking difference was in the car's safety structure. The survival cells were much smaller and less sophisticated than modern designs. The carbon fiber monocoques provided decent protection in certain types of impacts, but they were vulnerable to specific types of crashes that would be survivable today. The HANDS device, which prevents basilar skull fractures, didn't exist yet. Neither did the stand halo device that protects drivers' heads from debris. Many of the safety innovations we take for granted today were developed as direct responses to accidents that happened during the 90s. Now, let's talk about something really wild: the fuel capacity and consumption rates of these cars. Unlike today's Formula One cars, which are limited to 100 kilograms of fuel per race, 90s cars could carry whatever fuel load the team thought was optimal for their strategy. This led to some interesting strategic considerations. Teams could choose to start the race with a heavy fuel load and run longer stints, or start light and rely on multiple pit stops. But carrying extra fuel made the car significantly heavier and slower, so teams had to balance the strategic advantage of longer stints against the performance penalty of extra weight. The fuel consumption rates were also much higher than today. These engines were essentially unregulated in terms of efficiency, so they burned fuel at whatever rate produced maximum power. Some cars were consuming fuel at rates that would empty a typical road car's tank in less than an hour of racing. But here's something fascinating. Teams were also experimenting with fuel strategies that involve starting the race with different fuel loads depending on grid position. A car starting from the back might take a heavy fuel load to run a completely different strategy from the leaders, hoping to gain track position through strategic pit stops. The pit stops themselves were dramatically different from today's choreographed 2-second tire changes. Refueling was allowed, which meant pit stops could last anywhere from 8 to 12 seconds depending on how much fuel needed to be added. The refueling equipment was essentially a high-pressure fuel hose that connected to the car through a specially designed port. But refueling was incredibly dangerous. The fuel was under high pressure, and any leak or spill could create a fire hazard. There were several incidents during the decade where cars caught fire during pit stops, creating dramatic and dangerous situations that were eventually deemed too risky to continue. The tire changes were also much slower than today. Teams typically had fewer crew members, and the equipment was less sophisticated. Wheel guns were heavier and less powerful, and the coordination required for a fast pit stop was less developed. A good pit stop in the 90s might take 8 to 10 seconds compared to today's sub-3-second stops. Let's talk about the electronics, because this is where 90s Formula One cars really show their age. For most of the decade, these cars had minimal electronic assistance. No traction control, no stability control, no launch control, and certainly no energy recovery systems. The driver aids that did exist were relatively primitive. Anti-lock braking systems were experimented with, but were generally considered to provide less control than a skilled driver's feel for the brake pedal. Traction control was introduced midway through the decade, but was much less sophisticated than modern systems. This meant that drivers had to control wheel spin purely through throttle application and driving technique. In wet conditions, this made the cars incredibly difficult to drive. Drivers needed exceptional car control skills to manage power delivery without electronic assistance. The data acquisition systems were also primitive compared to today's standards. Teams might have a few dozen sensors on the car, compared to hundreds on modern Formula One cars. The data was recorded but couldn't be transmitted in real time, so engineers had to wait until the car returned to the pits to analyze what was happening. Radio communication between drivers and pits was often unreliable and sometimes non-existent. Drivers were much more on their own during races, having to make strategic and technical decisions without constant input from the pit wall. Here's something that might blow your mind. The cost of these cars was actually relatively reasonable compared to today's Formula One budgets. A complete car might cost a few $1,000,000 to build, compared to the tens of millions required for a modern Formula One car. But the development costs were still enormous because teams had to build everything from scratch. There were no standard components, no cost caps, and no restrictions on development spending. Teams like Ferrari and McLaren were spending tens of millions of dollars per year on development, but smaller teams could still be competitive with more modest budgets. The engines were leased from manufacturers rather than developed in-house by most teams, which helped control costs but also meant teams had less control over their power units. Engine reliability was a constant concern, and engine failures were much more common than today. As we wrap up this deep dive into the wild world of 90s Formula One cars, it's clear that these machines represented a unique moment in motorsport history. They were simultaneously primitive and sophisticated, dangerous and spectacular, crude and refined. These cars required a completely different skill set from their drivers compared to modern Formula One. Physical strength, car control, and mechanical sympathy were just as important as pure speed. Drivers had to be part athlete, part engineer, and part daredevil. The 90s were the last decade before modern safety regulations, electronic driver aids, and standardized components transformed Formula One into the highly regulated sport it is today. These cars represented the final evolution of the raw, unfiltered racing machines that had defined Formula One since its inception. Looking back, it's remarkable that anyone survived driving these cars competitively. They were genuinely dangerous in ways that modern safety equipment and regulations have eliminated. But they were also pure in a way that modern Formula One cars, for all their technological sophistication, can never match. The legacy of 90s Formula One cars lives on in the memories of spectacular races, legendary drivers, and engineering innovations that pushed the boundaries of what was possible. They remind us of a time when Formula One was less predictable, more dangerous, and arguably more exciting than it has ever been since. If you found these facts as fascinating as I do, make sure to hit that like button and subscribe for more deep dives into motorsport history. What other aspects of 90s Formula One would you like to see covered? Drop your suggestions in the comments below, and I'll see you in the next video. What if I told you that Formula One cars from the 2000s were so aerodynamically advanced that they could theoretically drive upside down on a tunnel ceiling at speeds over 120 miles per hour? And that's just the beginning of the mind-bending engineering madness that defined this incredible decade of motorsport. The 2000s weren't just another era in Formula One history. This was the period when teams pushed the absolute boundaries of what was physically possible with a race car, creating machines so sophisticated that they bordered on science fiction. We're talking about vehicles that generated more downforce than their own weight, engines that revved higher than a motorcycle, and technology so advanced that much of it was eventually banned for being too effective. Today, I'm going to take you inside the most fascinating decade in Formula One history, revealing secrets about these mechanical marvels that will completely change how you think about racing. From traction control systems that could make corrections 100 times per second to engines that consumed fuel at a rate that would empty your car's tank in under 10 minutes, The engineering achievements of 2000's F1 cars were nothing short of extraordinary. But here's what makes this era truly special. Unlike today's heavily regulated Formula One, teams in the 2000s had far more freedom to innovate. This led to some of the most creative and downright bizarre solutions to aerodynamic and mechanical challenges that the sport has ever seen. We're going to explore technologies that were so effective they had to be outlawed, design philosophies that defied conventional wisdom, and engineering approaches that pushed drivers to their absolute physical limits. Let's start with something that sounds impossible but was completely real. The aerodynamic packages on these cars were so sophisticated that at speeds above 120 miles per hour, they generated enough downforce to hold the car against a ceiling if you flipped it upside down. This wasn't theoretical engineering. Teams actually calculated this phenomenon and used it to understand just how much grip their cars could generate through corners. The secret lay in the complex interaction between the front wing, rear wing, side pods, and most importantly, the floor of the car. The entire bottom of a Formula One car from this era was essentially a giant wing carefully sculpted to create a low-pressure zone underneath the vehicle. This sucked the car down onto the track with incredible force. Combined with the traditional wings, some cars were generating downforce equivalent to twice their own weight at high speeds. But generating that much downforce came with a cost that most people never consider. The aerodynamic drag from all these wings and aerodynamic devices meant that engines had to work exponentially harder to maintain speed. This is where the power units of the 2000s became truly remarkable. During this decade, Formula One engines were 3-liter naturally aspirated V10 and later V8 power plants that could rev to stratospheric heights. We're talking about engines that routinely operated at 19,000 revolutions per minute, with some experimental units reaching beyond 20,000 revolutions per minute during testing. To put this in perspective, most road car engines redline around 6,000 to 8,000 revolutions per minute. These F1 engines were spinning nearly 3 times faster while producing over 900 horsepower from just 3 liters of displacement. The engineering required to make components survive at these rotational speeds was extraordinary. Pistons were accelerating and decelerating so rapidly that the forces involved were measured in hundreds of Gs. The connecting rods, crankshafts, and valve train components had to be manufactured to tolerances measured in thousandths of inches using exotic materials that cost more per pound than gold. Here's something that will blow your mind about fuel consumption. These engines were so thirsty for fuel that they consumed it at a rate of approximately 2 miles per gallon during racing conditions. A typical Formula One car from the 2000s carried about 100 kilograms of fuel at the start of a race, which sounds like a lot until you realize that this had to last for nearly 2 hours of flat-out racing. Teams became obsessed with fuel efficiency, not for environmental reasons, but because carrying extra fuel meant carrying extra weight, which made the car slower. The fuel itself wasn't ordinary gasoline either. Formula One teams use specially formulated racing fuels with octane ratings that could exceed 120, compared to the 91 to 93 octane fuel you put in your road car. These fuels were designed to burn more efficiently and resist knocking under the extreme pressures and temperatures inside these high-revving engines. Now let's talk about something that made these cars almost supernatural in their capabilities: electronic driver aids. During the early 2000s, Formula One cars were equipped with traction control systems that made corrections so rapidly that human drivers couldn't even perceive them happening. These systems monitored wheel slip 100 times per second and could selectively apply brakes to individual wheels or reduce engine power with millisecond precision. The traction control systems were so advanced that they could detect the exact moment when a tire was about to break traction and intervene before the driver even realized there was a problem. This allowed drivers to attack corners with an aggression that would have been impossible with purely mechanical cars. The downside was that it somewhat diminished the role of driver skill, which is ultimately why these systems were banned. But traction control wasn't the only electronic wizardry at work. These cars also featured launch control systems for race starts that could manage clutch engagement and throttle application better than any human driver. Some teams developed systems so sophisticated that they could account for Luderpunkt, factors like ambient temperature, track surface conditions, and even the exact weight distribution of fuel in the tank. The braking systems on these cars were equally impressive and pushed the boundaries of materials science. Carbon fiber brake discs could withstand temperatures exceeding 1,000 degrees Celsius without failing. During heavy braking zones, these discs would glow cherry red and could be seen clearly even in daylight. The brake pads were made from carbon compounds that actually became more effective as they heated up, the opposite of conventional brake materials. Here's something fascinating about the tire technology. During this era, teams had access to multiple tire compounds from suppliers like Bridgestone and Michelin, and the competition between these manufacturers led to incredible innovations. Some tires were designed to work optimally only within very narrow temperature windows, requiring teams to use tire blankets that heated the rubber to precise temperatures before installation. The tire wars of the mid-2000s produced rubber compounds so soft and grippy that they could lose significant performance after just a few laps of hard driving. Teams had to develop completely new strategies around tire management, sometimes planning entire race strategies around when to change tires for optimal performance. This created a chess match element to racing that added incredible strategic depth. Weight distribution became an obsession during this era, with teams going to extreme lengths to position every component for optimal balance. Engineers would spend weeks calculating the ideal placement of components weighing just a few ounces. Ballast weights were moved around the car with surgical precision, sometimes being relocated between practice sessions to fine-tune handling characteristics for specific track conditions. The steering systems on these cars incorporated power assistance that was calibrated differently for each driver's preferences and even adjusted based on fuel load as the race progressed. Some drivers preferred heavier steering feel for better feedback, while others wanted lighter assistance to reduce fatigue during long races. Teams could adjust these parameters remotely from the pit wall during races. Data acquisition systems from this era were incredibly sophisticated, monitoring hundreds of parameters in real time and transmitting telemetry back to teams via radio links. Engineers could watch every aspect of the car's performance live during races and communicate setup changes to drivers through sophisticated radio systems. This level of real-time monitoring and adjustment was unprecedented in motorsport. Safety technology also advanced dramatically during the 2000s, though often in response to tragic events. The HANS device became mandatory, protecting drivers' heads and necks during impacts. Carbon fiber survival cells were strengthened and refined, and impact-absorbing structures were designed to manage crash energy more effectively. These safety innovations saved countless lives and influenced automotive safety development across all racing series. The manufacturing processes used to build these cars were cutting edge even by aerospace industry standards. Carbon fiber components were crafted using autoclave curing processes that created materials stronger than steel while weighing a fraction as much. Teams employed advanced computer modeling to optimize component shapes for maximum strength-to-weight ratios. Here's something that might surprise you about driver fitness requirements. The physical demands on drivers during this era were extraordinary, largely because of the massive G-forces generated by the aerodynamic downforce. Drivers experienced lateral G-forces exceeding 4 Gs through high-speed corners, meaning their heads effectively weighed 4 times normal during these maneuvers. Training regimens focused heavily on neck strength and cardiovascular endurance. The cooling systems required to keep these cars operating were marvels of engineering efficiency. Radiators had to dissipate enormous amounts of heat while adding minimal weight and drag. Some teams experimented with exotic cooling methods, including systems that used the fuel itself as a cooling medium before it reached the engine. Suspension systems became incredibly sophisticated, with some teams developing adaptive damping systems that could adjust their characteristics in real time based on track conditions and driving inputs. These systems used electronic sensors to detect road surface irregularities and adjust suspension response within milliseconds. As we move through the decade, regulation changes constantly force teams to reinvent their approaches. The switch from V10 to V8 engines in 2006 required completely new power unit designs. The elimination of electronic driver aids forced engineers to develop mechanical solutions to maintain performance levels. Each regulatory change sparked new waves of innovation. The cost of developing and operating these technological marvels was astronomical. Top teams spent hundreds of millions of dollars annually, employing thousands of engineers, mechanics, and support personnel. Wind tunnel testing programs ran 24 hours a day, with scale models being tested in conditions that simulated every possible racing scenario. The legacy of 2000s. Formula One technology extends far beyond motorsport. Innovations developed for these race cars influenced everything from road car aerodynamics to advanced materials manufacturing. The carbon fiber techniques pioneered in F1 eventually found applications in aerospace, medical devices, and consumer electronics. Looking back at this incredible decade, It's clear that the 2000s represented a unique moment in Formula One history, when technological innovation was largely unrestricted by regulations. The result was a period of unprecedented engineering achievement that pushed the boundaries of what was possible with ground vehicles. These weren't just race cars. They were rolling laboratories that advanced human understanding of aerodynamics, material science, and mechanical engineering. The next time you watch modern Formula One, remember that today's cars, while impressive, are actually less technologically advanced in many ways than their 2000s predecessors. Current regulations have deliberately restricted many of the innovations that made the cars from this era so extraordinary, prioritizing cost control and competitive balance over pure technological advancement. What fascinates me most about this era is how it demonstrated that when brilliant engineers are given freedom to innovate, they can create machines that seem to defy the laws of physics, while actually exploiting those laws in ways that push the absolute limits of what's possible. Did you know that in 1988, McLaren won 15 out of 16 Formula One races, making it the most dominant season in F1 history? But here's the crazy part. That incredible achievement almost never happened because of a bizarre rule change that nearly destroyed the team before the season even began. Welcome back to the channel. And today we're diving deep into the wild world of 1,980 seconds, Formula One, where teams were pushing the absolute limits of technology, politics, and pure insanity. The 80s weren't just about neon colors and synthesizers. This was the decade when F1 teams became genuine tech companies, spent money like there was no tomorrow, and pulled off some of the most audacious moves in motorsport history. Before we get started, make sure you hit that subscribe button because we're about to uncover some absolutely mind-blowing facts that even hardcore F1 fans probably don't know. And trust me, by the end of this video, you'll understand why the 1,980 seconds were arguably the most innovative and chaotic decade in Formula One history. Let's start with something that sounds completely made up but is absolutely true. The Brabham team once decided that instead of making their car faster, they'd make their pit stops faster by developing a system that could refuel their car in under 4 seconds. This wasn't just impressive, it was revolutionary. Gordon Murray, their brilliant designer, created a system so advanced that it became the template for modern F1 pit stops decades later. But here's where it gets really interesting. Brabham wasn't just innovating with pit stops, they were literally cheating the system in the most ingenious way possible. In 1981 and 1982, they developed what they called the hydropneumatic suspension system. Sounds boring, right? Wrong. This system allowed their car to pass the mandatory ride height checks in the pits, but then automatically lower itself once it hit the track, giving them a massive aerodynamic advantage. The FIA inspectors would measure the car, everything would check out perfectly, and then the car would hit the track and suddenly become a ground effect monster. It took the governing body months to figure out what was happening, and by then, Nelson Piquet had already won the 1,981 World Championship using this system. That's not just clever engineering, that's next-level strategic thinking. Speaking of clever engineering, let's talk about the Ferrari story that nobody tells. Everyone knows Ferrari as this legendary Italian team, but during the mid-80s, they were actually struggling massively with their technology. Their engines were powerful but unreliable. Their aerodynamics were outdated and their strategic decisions were questionable at best. But then something incredible happened in 1985. Ferrari hired Harvey Postlethwaite, a British aerodynamicist who had previously worked with smaller teams. Postlethwaite looked at Ferrari's approach and basically said they were doing everything wrong. Instead of trying to build the most powerful engine possible, he focused on creating a complete package that balanced power, reliability, and aerodynamics. The result? Ferrari went from being also-rans to genuine championship contenders almost overnight. Michele Alboreto came incredibly close to winning the 1,985 World Championship, losing out only because of reliability issues in the final races. But here's the kicker. Postlethwaite achieved this transformation with essentially the same budget Ferrari had been wasting for years. It wasn't about spending more money, it was about spending it smarter. Now let's talk about Williams, because their story from the 80s is absolutely insane. Frank Williams had built his team from literally nothing. He started by buying a single Brabham chassis and running it out of a tiny garage. By the early 80s, Williams was becoming competitive, but they were still considered underdogs compared to the big manufacturers. Then, Patrick Head, their chief designer, made a decision that changed everything. Instead of trying to compete with the established manufacturers on their terms, Williams decided to become the best customer team in F1 history. They formed a partnership with Honda that would define the decade. Honda had just returned to Formula One after a long absence, and they were looking for a team that could maximize their engine's potential. Williams wasn't the most obvious choice. McLaren had more resources, Ferrari had more prestige, and Lotus had more experience with ground effects. But Williams offered something different: complete technical integration. The Williams-Honda partnership wasn't just about bolting a Honda engine into a Williams chassis. Head and his team worked directly with Honda's engineers to optimize every aspect of the car around the engine. They shared data, coordinated development, and essentially became Honda's de facto factory team without actually being owned by Honda. The results speak for themselves. Nelson Piquet won the 1987 World Championship driving a Williams Honda, and the team consistently competed at the front throughout the mid to late 80s. But here's the really impressive part. Williams achieved this while remaining an independent team. They proved that you didn't need manufacturer backing to compete at the highest level. You just needed the right partnerships and the intelligence to maximize them. But if we're talking about intelligence and innovation, we absolutely have to discuss Lotus and their ground effects revolution. Colin Chapman had already established Lotus as one of the most innovative teams in F1 history, but the late 70s and early 80s were when they truly changed the sport forever. The Lotus 78 and 79 introduced ground effects to Formula One, using aerodynamics to literally suck the car onto the track. This wasn't just a minor improvement, it was a complete paradigm shift that made every other car on the grid instantly obsolete. Teams that had spent years perfecting traditional aerodynamic approaches suddenly found themselves completely outclassed. But here's what most people don't realize about the ground effects era. It almost killed several drivers and led to some of the most terrifying accidents in F1 history. The cars generated so much downforce that when the ground effect seal broke, which could happen if the car hit a bump or went over a curb wrong, the car would instantly lose massive amounts of grip with no warning. Chapman realized this was a problem, but instead of abandoning ground effects, he doubled down and tried to make them safer. The Lotus 81 and 88 were attempts to create ground effect cars that could maintain their aerodynamic performance while being more forgiving when things went wrong. Unfortunately, Chapman died in 1982 before he could fully develop these concepts, and Lotus never quite recovered from losing their visionary leader. This brings us to one of the most fascinating aspects of 80s, F1, the role of technology suppliers. Today, we think of teams like Mercedes, Ferrari, and Red Bull as the primary innovators, but in the 80s, much of the real innovation was happening at companies most fans had never heard of. Take March Engineering, for example. They weren't running their own F1 team during most of the 80s, but they were designing and building chassis for multiple teams. Robin Hurd and his team at March were responsible for some of the most advanced F1 cars of the decade, even though they rarely got credit because the cars carried other teams' names. Similarly, companies like Reynard, Lola, and Dallara were developing F1 technology that would eventually filter down to other motorsport categories. The 80s F1 scene was essentially a giant research and development laboratory that was pushing the boundaries of what was possible with automotive technology. And then there's the Cosworth story, which might be the most impressive of all. Cosworth had dominated F1 engine supply throughout the 70s with their DFV engine. But by the early 80s, turbo engines were making naturally aspirated engines obsolete. Instead of giving up, Cosworth decided to develop their own turbo engine. The Cosworth GBA turbo engine was a masterpiece of engineering that proved you didn't need manufacturer resources to compete with Honda, BMW, and Ferrari. Teams using Cosworth engines were consistently competitive throughout the mid-80s, and the engine was so well designed that it remained competitive even as other manufacturers threw massive resources at development. But perhaps the most mind-blowing story from 80s F1 involves Benetton and their transformation from clothing company to F1 powerhouse. Luciano Benetton decided he wanted to get into Formula One, but instead of starting from scratch, he bought the struggling Toleman team in 1985. What happened next was basically a masterclass in how to build a successful F1 team. Benetton hired Flavio Briatore as team manager, brought in experienced designers like Rory Byrne, and slowly built up their technical capabilities. But the really clever part was how they approached driver development. While other teams were paying massive salaries for established stars, Benetton focused on finding young drivers with raw talent and developing them within their system.
This approach led them to discover drivers like Michael Schumacher, who would eventually become one of the greatest F1 drivers of all time. The Benetton story shows that success in F1 wasn't just about having the biggest budget or the most advanced technology. It was about having a clear vision, making smart strategic decisions, and being willing to take calculated risks on unproven talent. Now let's talk about something that sounds completely insane but actually happened. The 1989 season finale between McLaren teammates Ayrton Senna and Alain Prost. These two drivers absolutely despised each other, and their rivalry came to a head during the Japanese Grand Prix in a collision that essentially decided the World Championship. But here's the part that most people don't know. The collision wasn't really about the championship. By that point in the season, Senna needed to win every remaining race to beat Prost, so both drivers knew exactly what was at stake. The collision happened because both drivers were trying to prove a point about who was the better driver, regardless of championship implications. The aftermath was even more dramatic than the collision itself. Senna was initially disqualified for receiving outside assistance after the crash, handing the championship to Prost. But McLaren appealed the decision, leading to months of political maneuvering that exposed just how much politics influenced F1 decision-making. Eventually, Senna was reinstated as the race winner, but by then, the championship was already decided. The whole controversy showed that 80s F1 wasn't just about driving fast, it was about navigating complex political relationships between teams, drivers, sponsors, and governing bodies. This political complexity reached its peak with the FISA-FOCA War, which sounds like something out of a spy novel but was actually a real conflict that nearly destroyed Formula One. FISA represented the manufacturers and established teams, while FOCA represented the smaller independent teams. The conflict was ostensibly about technical regulations and commercial rights, but it was really about control of the sport's future direction. Bernie Ecclestone, representing FOCA, wanted F1 to become more commercially oriented and television-friendly. Jean-Marie Balestre, representing FISA, wanted to maintain traditional manufacturer involvement and technical complexity. The war played out through rule changes, boycotts, and behind-the-scenes negotiations that would have made Cold War diplomats proud. Teams would show up to races not knowing if their cars were legal, drivers would practice in cars that might be excluded before qualifying, and entire race weekends would be thrown into chaos by last-minute rule interpretations. But here's the fascinating part. This conflict actually made F1 better. The eventual compromise between FISA and FOCA created the framework for modern Formula One, including standardized technical regulations, centralized commercial management, and more equitable revenue distribution among teams. The 80s also gave us some of the most innovative marketing approaches in F1 history. Teams realized that success on track wasn't enough. They needed to build brands that resonated with fans and sponsors. This led to some incredibly creative partnerships and promotional campaigns. Marlboro's partnership with McLaren wasn't just about slapping logos on a car. It was a complete brand integration that included driver development, team presentation, and even influencing car design to maximize logo visibility. Similarly, Canon's sponsorship of Williams led to some of the most iconic F1 liveries of all time. But the most interesting marketing story involves Benetton and their use of fashion industry expertise to revolutionize F1 team presentation. They treated their F1 team like a fashion brand, focusing on visual impact, driver styling, and creating a complete aesthetic experience that went far beyond traditional motorsport marketing. As we wrap up this journey through 80s F1 madness, it's worth reflecting on why this decade was so special. The 80s represented a perfect storm of technological innovation, regulatory flexibility, and financial resources that created an environment where teams could genuinely revolutionize the sport. Today's F1 is incredibly sophisticated, but it's also heavily regulated and standardized. Teams can't develop radically different approaches because the rules are so restrictive. In the 80s, teams could genuinely out-innovate their competitors through pure engineering brilliance and creative rule interpretation. The stories we've covered today, from Brabham's ride height tricks to McLaren's 1988 dominance, from Williams-Honda partnership to Benetton's driver development program, IFT, show that success in F1 has always been about more than just driving fast. It's been about intelligence, innovation, and the willingness to challenge conventional thinking. So the next time someone tells you that modern F1 is the pinnacle of motorsport technology, remind them that the real innovations happened 40 years ago, when teams were willing to try anything, spend everything, and push every boundary to gain a competitive advantage. If you enjoy diving into these incredible stories from F1's golden age of innovation, make sure to subscribe for more deep dives into motorsport history. Hit that like button if you learned something new, and let me know in the comments which 80s F1 story surprised you the most. Until next time, keep pushing the limits. Did you know that in the 1,990 seconds, one Formula One team was so broke they literally had to choose between buying new tires or paying their electric bill? And another team's biggest sponsorship deal came from a company that didn't even exist yet? Buckle up, because the wild world of 90 seconds Formula One is about to blow your mind with stories so crazy you won't believe they actually happened. The 1,990 seconds were absolutely insane for Formula One. This wasn't just racing, this was pure chaos, wrapped in carbon fiber and dipped in octane. We're talking about an era where teams would show up to races with cars held together by hope and duct tape, where million-dollar sponsorship deals were made on napkins in hotel bars, and where the line between genius and madness was thinner than a racing slick at the end of a Grand Prix. Let me paint you a picture of just how wild things were. Picture this. It's 1,991, and the Jordan Grand Prix team, yes, that Jordan, the one that would eventually become today's Aston Martin, literally didn't have enough money to get their cars to the first race of the season. Michael Jordan, the basketball legend? Nope. We're talking about Eddie Jordan, an Irish former dentist turned team owner who had the audacity to think he could take on Ferrari and McLaren with essentially pocket change and pure Irish stubbornness. But here's where it gets absolutely bonkers. Jordan didn't just find a way to get to that first race. He somehow convinced a young driver named Michael Schumacher to make his Formula One debut with his team. Now, Schumacher only drove one race for Jordan before being poached by Benetton, but that single race appearance would later become legendary. Jordan's team was so cash-strapped that they couldn't even afford to keep the driver who would go on to become one of the greatest of all time. Imagine being so broke you accidentally discovered the next Michael Jordan of motorsport and then had to watch him leave because you couldn't afford to keep him. Speaking of money problems, let's talk about the Minardi team, the ultimate underdogs of Formula One. These guys were the definition of doing more with less. Throughout the 90 seconds, Minardi operated on budgets that were smaller than what the big teams spent on their coffee machines. I'm not even exaggerating here. Their entire yearly budget was sometimes less than what McLaren spent on wind tunnel testing in a single month. But Giancarlo Minardi and his team had something that money couldn't buy: heart and creativity that would make MacGyver jealous. They once showed up to a race with a car that was painted with house paint because they couldn't afford proper automotive paint. House paint. The same stuff you'd use to touch up your bathroom walls was being used on a Formula One car traveling at 200 miles per hour. And somehow, some way, that car not only didn't fall apart, it actually finished the race. The creativity didn't stop there. Minardi became famous for what the paddock called Italian engineering magic. They would take parts from completely different cars, modify them with nothing but basic hand tools and pure determination, and somehow make them work. Their mechanics were like automotive wizards, turning spare parts into competitive racing components through sheer force of will and probably a lot of espresso. Now let's dive into one of the most spectacular rise and fall stories of the decade, the Andrea Moda Formula team. If you've never heard of Andrea Moda, consider yourself lucky, because this team was a masterclass in how to destroy a Formula One operation in record time. Andrea Sassetti bought the struggling Coloni team in 1992 with big dreams and even bigger promises. He claimed he was going to revolutionize Formula One with innovative designs and unlimited funding. What actually happened was more like a very expensive practical joke that nobody was laughing at. Andrea Moda showed up to races with cars that looked like they were designed by someone who had only heard Formula One described over a bad phone connection. Their cars were so unreliable that they made Minardi look like Mercedes. In one infamous incident, their car's steering wheel came off in the driver's hands during practice. Not broke, not malfunctioned, literally came off and was just sitting there in the driver's lap while the car careened toward a barrier. The team's approach to safety was equally questionable. They once tried to enter a race with a car that hadn't passed any of the mandatory safety inspections. When officials asked about their safety certifications, Andrea Moda representatives apparently handed over documents that looked like they were created on a typewriter the night before. The whole operation lasted exactly 1 season before being banned from Formula One forever, which honestly might have been for the best considering their cars were basically rolling safety hazards disguised as race cars. But not every underdog story ended in disaster. Let's talk about Stewart Grand Prix, founded by 3-time world champion Jackie Stewart and his son Paul. When they entered Formula One in 1997, nobody expected much from the Scottish father-son duo. Most people figured they'd be another small team struggling to survive in the back of the pack. Jackie Stewart had other plans. This man took everything he learned from decades of racing and applied it to team management with the precision of a Swiss watchmaker. Stewart Grand Prix didn't just want to participate. They wanted to win. And they had a plan to make it happen that was equal parts brilliant and audacious. The team's attention to detail was absolutely obsessive. While other teams were cutting corners to save money, Stewart was investing in areas that most people didn't even think about. They had dedicated staff members whose only job was to ensure that every single bolt on their cars was tightened to the exact specification. They employed meteorologists to predict weather conditions with NASA-level precision. They even had someone whose job was to analyze the psychological state of their drivers and optimize their mental performance. This attention to detail paid off in ways that shocked the entire Formula One world. In their very first season, Stewart Grand Prix scored points, something that many new teams struggled to do for years. But their real breakthrough came in 1999 at the European Grand Prix at the Nürburgring. Johnny Herbert, driving for Stewart, didn't just finish well, he won the entire race. A team that had only existed for 3 years had just defeated Ferrari, McLaren, and every other established powerhouse on the grid. The celebration in the Stewart garage was unlike anything Formula One had seen. Jackie Stewart, the man who had risked his life racing in an era when drivers regularly died on track, was crying tears of joy as his team achieved what many thought was impossible. It was proof that in Formula One, sometimes the biggest heart could beat the biggest wallet. Now let's shift gears and talk about one of the most bizarre sponsorship deals in sports history. The Arrows team, throughout the 90 seconds, was known for having some unusual sponsors. But nothing prepared the Formula One world for their partnership with a company called Champ Car World Series. Here's the kicker. Champ Car World Series was a competing racing series. Imagine if the New York Yankees had Coca-Cola sponsor their uniforms while they were owned by Pepsi. It was that level of confusing. But the sponsorship world of 90 Seconds Formula One was full of these surreal partnerships. Teams would literally put any company's logo on their cars if they paid enough money, leading to some truly bizarre combinations. You had cigarette companies sponsoring cars driven by drivers who had never smoked, alcohol brands on cars in countries where alcohol was illegal, and technology companies that were using Formula One to advertise products that wouldn't be invented for another decade. The most legendary sponsorship story belongs to the Benetton team and their relationship with the United Colors of Benetton Clothing Company. Luciano Benetton didn't just want to sponsor a Formula One team, Bay and Day. He wanted to use Formula One as a way to promote his brand's message of global unity and multiculturalism. This led to some of the most colorful and distinctive car designs in Formula One history. Benetton cars looked like they had been painted by someone who had access to every color in the spectrum and wasn't afraid to use them. Bright blues, electric greens, shocking pinks. These cars looked more like abstract art pieces than racing machines. But here's the genius part. Those wild color schemes made Benetton cars instantly recognizable on television. Even casual viewers who couldn't tell a Ferrari from a McLaren could spot a Benetton from across the track. The strategy worked beyond anyone's wildest expectations. Benetton's Formula One involvement coincided with massive growth in their clothing business worldwide. People who had never heard of the brand suddenly wanted to wear the same colors they saw dominating on racetracks. Formula One had become the ultimate fashion runway, traveling the world at 200 miles per hour. But let's talk about the technical side of things, because the 90 seconds were a golden age of automotive innovation that makes today's hybrid technology look simple by comparison. Teams were experimenting with active suspension systems that could literally think and adjust to track conditions in real time. We're talking about computers that could make thousands of calculations per second to optimize a car's performance through every single corner. Williams was the pioneer of this technology, and their active suspension system was so advanced it seemed like science fiction. The car would scan the track ahead using sensors, predict exactly what kind of suspension setup would be optimal for the next section of track, and then automatically adjust itself before the driver even knew what was coming. It was like having a crystal ball that could see into the future and prepare your car accordingly. The system was so effective that Williams dominated the early 90 seconds with a technological advantage that was almost unfair. Their cars would glide over track surfaces that would bounce other cars around like pinballs. But here's where Formula One's tendency toward chaos kicks in. The technology was so expensive and complicated that it eventually became a reliability nightmare. Cars that could predict the future couldn't predict their own mechanical failures. McLaren took a completely different approach to innovation. Instead of trying to build the smartest car, they decided to build the most adaptable car. Their philosophy was that races were won not by having the perfect setup, but by having a car that could perform well in any conditions. This led to some of the most versatile racing machines ever built. The McLaren MP4 series cars from the 90 seconds were like the Swiss Army knives of Formula One. They might not have been the fastest in qualifying, but they could handle wet weather, dry weather, hot tracks, cold tracks, smooth circuits, and bumpy street courses with equal competence. While other teams were building cars that were perfect for specific conditions, McLaren was building cars that were good at everything. This philosophy paid massive dividends during unpredictable race weekends. When weather conditions changed suddenly, or when track surfaces provided unexpected challenges, McLaren drivers would suddenly find themselves at the front of the pack, while more specialized cars struggled to adapt. It was proof that sometimes being good at everything was better than being perfect at one thing. The human stories from this era are just as fascinating as the technical ones. Take the story of Jean Alesi, the French driver who spent most of the 90 seconds driving for Ferrari. During some of their most frustrating years, Alesi was incredibly talented. Many experts believed he had the skill to win multiple world championships, but he had the misfortune of joining Ferrari during a period when their cars were beautiful, passionate, and completely unreliable. Race after race, Alesi would qualify well, drive brilliantly, and then watch his Ferrari break down in spectacular fashion. Engine failures, transmission problems, electrical issues, it seemed like every possible mechanical failure happened to Alesi's cars. But here's what made him legendary. He never gave up, never complained publicly, and never lost his love for racing, despite the constant heartbreak. Alesi's dedication to Ferrari during their difficult years earned him a special place in the hearts of Italian fans. They saw him as someone who truly understood what Ferrari represented, not just winning, but racing with passion, regardless of the consequences. His single victory at the 1995 Canadian Grand Prix was celebrated in Italy like a national holiday, because fans knew how much he had sacrificed and suffered to achieve that moment of triumph. The 90 seconds also gave us some of the most dramatic season finales in Formula One history. The 1994 championship battle between Michael Schumacher and Damon Hill came down to the final race in Adelaide, with both drivers having legitimate chances to win the title. The tension was so thick you could cut it with a knife, and when Schumacher and Hill collided during the race, it created one of the most controversial moments in sports history. What made that collision so significant wasn't just that it decided the championship, it was that it perfectly encapsulated the wild, unpredictable nature of 90 seconds Formula One. This was an era where anything could happen, where seasons could be decided by split-second decisions, mechanical failures, or pure luck. Every race felt like a high-stakes drama where careers, championships, and legacies hung in. The balance. The aftermath of that collision created divisions in the Formula One community that lasted for years. Some people believed Schumacher deliberately crashed into Hill to win the championship. Others argued it was a racing incident that looked worse than it actually was. The truth probably lies somewhere in between, but the controversy added another layer to the mythology of 90 seconds Formula One. As we look back at this incredible decade, it's clear that the 1990 seconds represented a unique moment in Formula One history. It was the perfect storm of technological innovation, financial uncertainty, larger-than-life personalities, and pure automotive passion. Teams were inventing the future while simultaneously struggling to pay their bills. Drivers were pushing the boundaries of human performance, while racing cars that were barely controlled chaos machines. The 90 seconds proved that in Formula One, the most important ingredient isn't money or technology. It's the human spirit of competition and innovation. Teams like Jordan, Stewart, and Minardi showed that with enough creativity, determination, and maybe a little bit of madness, anyone could challenge the established order and create something extraordinary. That decade laid the foundation for everything we see in modern Formula One, from the technical regulations to the global popularity of the sport. But more than that, it created legends and stories that continue to inspire new generations of racing fans. The 1,990 seconds weren't just about who won championships. They were about proving that in the right circumstances, with the right people, absolutely anything was possible in the world of Formula One racing. What if I told you that one Formula One team in the 2000s was so desperate to find speed that they literally hired a witch doctor to curse their competitors? And that's just the beginning of the absolute madness that defined this incredible decade in motorsport history. Buckle up, because we're about to dive into the most shocking, bizarre, and downright unbelievable random facts about Formula One teams from the 2000s that will completely change how you see this sport forever. The 2000s were arguably the most dramatic decade in Formula One history, filled with legendary battles, technological breakthroughs, and behind-the-scenes chaos that would make even the wildest soap opera seem tame. From teams that cheated so creatively they rewrote the rulebook, to drivers who pulled off stunts that defied physics and logic, this decade had it all. But here's what most fans don't know about their favorite teams from this era. The stories I'm about to share with you go way beyond what you saw on race day. These are the secrets, the scandals, and the absolutely insane moments that happened when the cameras weren't rolling. And trust me, some of these facts are so wild that even die-hard Formula One fans will be shocked. Let's start with Ferrari, the most iconic team in Formula One history. Everyone knows about their dominance with Michael Schumacher. But here's what they don't tell you about the Scuderia in the 2000s. Ferrari had a secret testing facility that was so advanced, it made their official headquarters look like a garage workshop. Hidden away in the Italian countryside, this facility was where they developed some of the most revolutionary aerodynamic concepts ever seen in Formula One. But the real kicker? Ferrari employed a team of former NASA engineers who had worked on the space shuttle program to design their wind tunnel systems. These weren't just any engineers. These were the same people who had calculated trajectories for spacecraft traveling to Mars. And they applied that same precision to making a racing car go faster around a track. The level of scientific expertise was so intense that some Ferrari engineers needed security clearance typically reserved for military projects. Speaking of Ferrari's obsession with perfection, did you know they had a color laboratory dedicated entirely to getting their famous red paint exactly right? This wasn't just mixing some red paint and calling it a day. Ferrari employed chemists who spent months perfecting the exact shade of Rosso Corsa, testing how it would look under different lighting conditions at various racetracks around the world. They even factored in how television cameras would capture the color, because they knew that millions of fans would be watching on TV. Now let's talk about McLaren, and this is where things get really interesting. During the early 2000s, McLaren had a partnership with Mercedes. But what most people don't realize is that this partnership was so secretive that McLaren employees weren't allowed to discuss technical details with Mercedes engineers unless they were in a specially constructed soundproof room at the McLaren Technology Center. The reason for this paranoia? Industrial espionage was rampant in Formula One during this period. Teams were so worried about competitors stealing their secrets that McLaren actually hired former intelligence officers to conduct security sweeps of their facilities. These weren't just basic security checks. We're talking about the same people who had worked for government agencies, using equipment that could detect listening devices smaller than a coin. But here's the truly bizarre part about McLaren in the 2000s. Ron Dennis, the team principal, was so obsessed with cleanliness and precision that he had the floors of the McLaren factory polished to such a shine that visitors often mistook them for mirrors. Employees were required to wear special shoe covers, and any piece of equipment that showed even the slightest sign of wear was immediately replaced, regardless of whether it was still functional. This obsession with perfection extended to their hospitality areas at racetracks. McLaren's catering staff were trained by professional chefs from five-star restaurants, and every meal served to team members was photographed and cataloged to ensure consistent presentation. They even had a full-time employee whose only job was to ensure that McLaren's branded materials were perfectly aligned and wrinkle-free at all times. Moving on to Williams, and this team had some of the most fascinating innovations of the decade that nobody talks about. Williams developed a simulator system that was so advanced, it could predict tire degradation patterns with scary accuracy. But here's the kicker. They achieved this by partnering with video game developers who had created physics engines for racing games. The Williams simulator wasn't just a fancy video game setup. It was a multi-million-dollar system that could replicate the exact aerodynamic characteristics of any Formula One circuit. Drivers would spend hours in this simulator, and the data they generated was so detailed that Williams could predict lap times within hundredths of a second before the car even hit the track. But Williams also had one of the most unusual employee benefits in Formula One history. Every team member, from engineers to mechanics, was given access to a professional racing instructor who would teach them how to drive on a racetrack. The theory was that if everyone understood what it felt like to drive at the limit, they would have better insight into developing the car. Some Williams employees became so good at track driving that they competed in amateur racing series on weekends. Now, let's dive into some of the smaller teams that had absolutely incredible stories. Minardi, the Italian team that was everyone's sentimental favorite, had a tradition that sounds like something out of a movie. Before every race weekend, team owner Paul Stoddard would personally cook a meal for the entire team using his grandmother's recipes. But Minardi's real secret weapon was their approach to driver development. They had a partnership with a driving school in Italy, where they would send promising young drivers to learn not just how to race, but how to understand every mechanical aspect of a Formula One car. Minardi drivers were required to spend time working as mechanics, learning to build engines, and even helping design aerodynamic components. This hands-on approach meant that Minardi drivers often had a deeper understanding of their cars than drivers from much bigger teams. While other teams protected their drivers from the technical side, Minardi insisted that their drivers be involved in every aspect of car development. This philosophy produced some incredibly knowledgeable racers who went on to have successful careers with larger teams. The Jaguar team, which competed from 2000 to 2004, had one of the most expensive failures in Formula One history, but for reasons you've probably never heard. Jaguar spent millions developing a revolutionary gearbox system that could shift gears in microseconds, faster than humanly possible to detect. The problem wasn't that it didn't work, it worked too well. The gearbox was so efficient that it gave drivers an unfair advantage, and the FIA was preparing to ban the technology before Jaguar had even perfected it. Rather than waste their investment, Jaguar secretly sold the technology to a company that manufactured gearboxes for military vehicles. So the next time you see an armored vehicle, there's a chance it's using transmission technology that was originally designed to help Eddie Irvine win Formula One races. Jaguar also had one of the most elaborate driver fitness programs ever conceived. They partnered with the British military to put their drivers through training exercises typically reserved for special forces. Drivers would spend weeks learning survival techniques, undergoing psychological stress tests, and participating in physical challenges that pushed human endurance to its limits. The reasoning behind this extreme training was that Formula One racing puts drivers under stress levels comparable to combat situations. Heart rates during a race often exceeded what soldiers experience in actual battlefield conditions. Jaguar wanted their drivers to be prepared for anything, and their training program reflected this philosophy. BMW, when they returned to Formula One in the 2000s, brought with them manufacturing precision that was almost ridiculous in its attention to detail. Every single component of a BMW Formula One car was manufactured to tolerances typically reserved for aerospace applications. We're talking about precision measured in micrometers, differences so small they couldn't be detected without specialized equipment. But BMW's real innovation was in data analysis. They developed computer systems that could process telemetry data in real time and make automatic adjustments to car setup during practice sessions. This wasn't just collecting data and analyzing it later. This was artificial intelligence, making split-second decisions about suspension settings and aerodynamic configurations while the car was on track. BMW also had a partnership with a German university where they conducted research into driver psychology. They wanted to understand exactly how stress, adrenaline, and fatigue affected driver performance. The research was so detailed that they could predict when a driver would make a mistake based on biometric data collected during the race. Toyota's entry into Formula One in 2002 brought with it a level of manufacturing expertise that was almost incomprehensible. Toyota built a Formula One facility in Germany that was essentially a small city dedicated entirely to racing. The facility had its own power plant, water treatment system, and even a small airport for transporting cars and equipment. But Toyota's most impressive achievement was their approach to reliability. They developed manufacturing processes so precise that their engines could run for thousands of miles without significant wear. The problem was that Formula One engines were designed to be replaced after every race weekend, so Toyota's incredible reliability was actually overkill for the application. Toyota also pioneered the use of virtual reality in Formula One car development. Engineers could put on VR headsets and literally walk around and through a digital version of the car, examining every component and making modifications in virtual space before building physical prototypes. This technology was so advanced that it wouldn't become commonplace in other industries for another decade. Red Bull's entry into Formula One started with purchasing the Jaguar team in 2004, but their approach was completely different from anything Formula One had seen before. Red Bull treated Formula One as a marketing exercise, but they backed up their marketing with serious engineering investment. They hired Adrian Newey, one of the greatest aerodynamicists in Formula One history, and gave him unlimited resources to design the fastest car possible. But Red Bull's real innovation was in team culture. They created an environment where young engineers and mechanics were encouraged to take risks and try unconventional solutions. Traditional Formula One teams were hierarchical and conservative, but Red Bull promoted a startup mentality where the best ideas could come from anyone, regardless of their position in the company. Red Bull also revolutionized Formula One hospitality. Their paddock facilities were designed to be as impressive as possible, with celebrity chefs, live entertainment, and amenities that rivaled luxury hotels. The message was clear. Red Bull was in Formula One to make a statement, and they were willing to spend whatever it took to ensure that statement was impossible to ignore. The technology transfer between Formula One teams and other industries during the 2000s was absolutely mind-blowing. Materials developed for Formula One cars found their way into medical devices, aerospace applications, and even consumer electronics. Carbon fiber manufacturing techniques perfected for racing car chassis were adapted to create prosthetic limbs that were stronger and lighter than anything previously available. Engine technology from Formula One influenced the development of hybrid powertrains for road cars years before environmental concerns made hybrids mainstream. Teams were experimenting with energy recovery systems and advanced combustion techniques that would eventually become standard in consumer vehicles. Even data analysis methods developed for Formula One found applications in completely unrelated fields. The real-time processing capabilities developed to analyze car performance were adapted for financial trading systems, weather prediction models, and even medical monitoring equipment. As we reach the end of this incredible journey through Formula One history, it's clear that the 2000s were a decade of unprecedented innovation, fierce competition, and absolutely insane behind-the-scenes stories that most fans never heard about. These teams weren't just racing cars, they were pushing the boundaries of human knowledge and technological capability in ways that influenced industries far beyond motorsport. The dedication, creativity, and sheer audacity of Formula One teams during this period created a legacy that continues to influence racing and technology today. From Ferrari's NASA engineers to McLaren's obsessive attention to detail, from Williams' revolutionary simulators to the smaller team's innovative approaches to driver development, every team contributed something unique to the sport's evolution. If you enjoyed discovering these incredible facts about Formula One teams from the 2000s, make sure to subscribe for more deep dives into motorsport. History. There are so many more untold stories from this amazing decade, and we've only scratched the surface of the innovations, scandals, and pure engineering brilliance that define this era. Hit that notification bell, because next week, we're diving even deeper into the technological secrets that gave certain teams their competitive edge. Trust me, you won't want to miss what's coming next.